Hello and welcome. In this video, we are going to take another look at the basics behind web development. And specifically, we are going to take a look at the domain name system or DNS system. We're also going to touch on IP addressing, specifically the v4 of the Internet Protocol IP address protocol. And we're going to see how it relates to accessing your favorite resource on a network using a friendly name. Now, this video is part of a larger series of videos that focuses on the principles of web development as well as networking. So let's go ahead and get started by looking at what is an IP address. Now, you may already be familiar a little bit with this if you've had to do any basic troubleshooting on your home network. The IP address is a numeric address that is assigned to the network interface in your laptop or desktop. It doesn't really matter whether it's a wireless or a traditional Ethernet card, but the idea is that it is then going to provide a mapping between that physical hardware and the resources on that particular device, or as we're going to see, the way in which you can fundamentally get access to a resource on any network, whether it be an intranet or on the internet. Now, the one that you're probably most familiar with is going to be the IP version 4. It is the older of the two that are currently in use, and it is one of two standards. Technically, there are others, but these are the two that are most predominant use. The IPv4 uses a 32-bit address, and if you're familiar with binary, you know that that means that it has potential values from 0 to 1, which means that if we're using a 32-bit address, that we have 2 to the 32nd possible combinations, or a little bit over 4 billion unique addresses. And those addresses can range from essentially all of those bits being 0 to all of those bits being 1. And you could see here that the way we present this is in groups of 8 bits. And so, for instance, if you take a look at the range here from 0 to 255, that would represent all of the possible combination of values from 0, 0, 0, all the way up to 1, 1, 1, 1. And you would then do that for the remaining 24 bits. Now, regrettably, we don't get access to all of those addresses. There are certain addresses that are reserved. And specifically, you'll see in the documentation that I've provided along with this presentation that there are, for instance, a range of local IP addresses that you can use on an intranet, as well as the local loopback addresses of the 127.0.0.1 type. And we also have IPv6. Now, why does IPv6 fundamentally exist? Well, it turns out the world needs more than 4 billion IP addresses, and fundamentally, that is one of the biggest benefits of IPv6. There are some additional features in the IPv6 standard, but fundamentally, we just want to recognize that it has more addresses at our disposal. And how is that accomplished? Well, it uses 128-bit addressing, which technically would allow for then 2 to the 128th possible combinations. As you can see here, it's going to be 3.4 times 10 to the 38th approximate number of IP addresses, IPv6 addresses. And again, they're grouped a little differently. It's 8 groups of 16 bits, and it's usually represented in hexadecimal. And I've given you the long format here for the range from the lowest possible IPv6 address all the way up to the highest one. Now, again, you probably want to go back and refresh your memory a little bit about how hexadecimal is represented, but effectively it represents values from 0 up to F. So there's a total of 16 possible values. And again, that would take 4 bits for you to represent a single hexadecimal value. Hence, you would need 16 bits then for each of the groups in an IPv6 address. Now, you don't have to worry too much. We aren't going to be using too much of IPv6 because fundamentally we can explain all the concepts that we need to know by simply using our IPv4. So the next step in our understanding then is going to be to look at what is the domain name system. Well, fundamentally what it does is it allows for you to have a friendly mapping between the name that you're comfortable with, for instance, your favorite resource, maybe it's your favorite news site or your favorite social media site, and the IP address associated with the web server that is hosting those resources. Now, it is not limited to simply web services, although that's what we're clearly going to be focusing on in this particular series. But you could see here by some of the examples that I've given you, for instance, a news source like www.cnn.com can get mapped then to the IP address 151.101.207.5. And you can see here that these are IPv4 addresses. Now, don't worry too much if you don't get the same IP addresses when we actually do our experiment in another video, where I show you how to figure out what the IP address of your favorite resources are. These are just meant to be examples so that you could see that fundamentally behind the scenes of these friendly names like CNN.com, Google.com, and uab.edu, that there is just an IPv4 address that responds. And you'll see when we do our demonstration that you can actually use that IP address to get to the same resources that you would otherwise utilize the name for. So continuing on with our understanding, you have here a sample DNS file. Now, I don't want to dig too deep into it, but again, I want to emphasize that effectively all it is a mapping between a friendly name or a friendly mapping between a name and the IP address that is associated with that particular resource. And you can see there's some rules associated with it. In this case, we're looking at a sample that is provided from the Red Hat Linux enterprise support pages that essentially sets up a DNS server as well as an FTP server and a mail server. And you can see, for instance, if we focus on that server 1, then server 1 is technically at an IP address of 10.0.1.5, so that basically if you were to put into your web browser or attempt to ping server1.example.com, that you should get a response from that IP address. Now, please note, if you try to do this from your command line on your computer, this example won't work because this is intended to be an example for instance, a private network or an intranet. But fundamentally, this is how your DNS is set up. And the idea is then you would have these trusted resources that are managed by a group of authorities, but particularly the Internet Corporation for Assigned Names and Numbers and the Internet Assigned Numbers Authority, that between the two handle the policies as well as the implementation of these authoritative DNS or domain name system servers. And at that point, then it becomes a simple client-server relationship. In other words, your client, being your laptop, your desktop, needs to find a resource on the internet. And so it queries what it recognizes as a trusted DNS server, and it simply gets the IP address back then that will facilitate the communication between, for instance, your laptop or desktop and your favorite website. You can also see that there are some rules associated with the structure of a name for a given resource on the internet. And generally speaking, they are going to fall under two categories, a three-tiered and a four-tiered approach, with the three-tiered approach being a little more common currently. But the idea is that you will have that top-level domain. In both of these examples, it'll be .com, followed by the second level domain or the example, and then the third level domain in the first example is going to be www, while the fourth level will be the server. And the idea is that essentially as you go left in the name, you become more specific. Now, that second example, again, is kind of fallen out of favor a little bit, but is fundamentally used when you are dealing with perhaps a large corporate network, and you can, for instance, have a DNS server associated just simply with that corporate network to allow for easy access to certain things on that network. Mail would be a great example of that, or an intranet web server. But again, that topic is more for discussion in a networking course. Fundamentally, what you should be getting out of this is the idea that there is a mapping between that friendly name, in other words, the one that is much easier to remember, and the actual IP address for that resource. Those records are held on a DNS server and simply queried by your laptop or desktop for whatever role or whatever reason you might need them to be accessed. Best example, of course, is that your web browser simply needs to know what the IP address is of the computer hosting your favorite web page. Now, continuing on with some of the basic rules, there is this concept again of a top-level domain. In the first example here, it was .com, but we'll see that there are actually several categories of top-level domains, not the least of which is the ARPA, or address and routing parameter area, which is fundamentally an infrastructure top-level domain. That's all you really need to know about it, because we aren't going to spend too much time on it. Instead, you want to probably be a little more familiar with the generic top-level domains and the country code top-level domains that are associated with a given country or region. Now, I'm going to take just a second to pull up the Wikipedia article that is associated with the top-level domains, because I do want to take a second to look at some of the generic top-level domains. And you can see here that you have a whole list of the top-level domains regarded by city. And you can also take a look at the full list here. For instance, we have .com, .org, .net, .edu, .gov, and so on. There's the infrastructure one, and as well as some of the more recent additions when there was an expansion in the allocation of top-level domains. And you can see, for instance, there's things like .apple, .audio, and so on. And there's quite an extensive list at this point. The other one that you should be interested in, again, is going to be the country level domains, country code top level domains. And as you would imagine, these just simply correlate to the country of origin for a specific site. Now, you can see here that, for instance, that there are a web extension of a top-level domain extension of .au for Australia, .be for Belgium, and so on. And you've probably already discovered this as you were browsing the web. Now, to finish off our discussion about the domain name system, I wanted to take a quick look at an example. This is off my laptop, and we'll talk a little bit more about how I got this information in a later video. But what I'd like to do real quick is just focus on the fact that I can get my IP address, my local laptop IP address. In this case, it's 192.168.1.83. Right off the bat, you should recognize that now as an IPv4 address. And additionally, you should recognize that as a private IP address, meaning that it is part of that 192.168 range of IP addresses. The second thing you should be looking for is the DNS server. And in this particular case, you'll see that I have a DNS server of 192.168.1.254. Now, that should probably bother you, or at least puzzle you just a little bit. And the idea is that this is now also a private IP address, which implies then that I have set up my own DNS server, that I have went through and cataloged all of the IP addresses on the internet and mapped them to their friendly names. In other words, that somewhere I have a record of the IP address associated with google.com. Well, that's not completely true. And in order to understand what's actually going on is that any traffic that needs a DNS request or needs a DNS query will simply go to 192.168.1.254. And then to understand where then that is being passed to, You then have to log in to your router. On the right side of the screen, you'll see that I've done just that. I've blocked out a couple of important fields here, but fundamentally you'll see that I have included my primary DNS, and you'll see in this case it is 68.94.156.111. Well, it turns out that is a DNS server for my internet service provider, or ISP. In this case, it is AT&T. Now, if you were curious about that particular IP address and you weren't completely comfortable with knowing that it just came from AT&T.com and that's it, well, you can also take a second to take that IP address and use a site like who.is to figure out who is the owner of that IP address. And in this case, what I've done is I put in that 68.94.156.111, and well, sure enough, it appears to be owned by the AT&T Corporation, and you can see there's a little more information about it. But fundamentally, that then is the DNS server that is responding to my requests. In other words, anytime I need DNS resolution, well, there you go. And you can see here also too, you have a sample IPv6 address in this case for the default gateway. And we're not going to spend too much time looking at the IPv6 addresses. You can also see that there is my link local IPv6, as well as, if you're interested, my MAC address for my wireless card. So hopefully you found this video useful. Again, we're going to do a little more practical application in just a few minutes in another video. But for now, if you've got any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.